This is part 1 of the video on section 1.2 on conditionals and biconditionals. In this video, we discuss the definition of the conditional statement, denoted in this way. In words, we can refer to this conditional statement in various ways. The most common ones are listed here. P implies Q, if P, then Q, Q if P, Q only if P, P is sufficient for Q, Q is necessary for P. All of these express the same thing. Conditional statements are some of the most important statements you'll see in all of mathematics, and many things that you prove can be written as a conditional statement. We want to understand what should be the truth table for P implies Q. In other words, we want to know its truth value as a function of the truth values of P and Q. There are four possible choices. P is true and Q is true. P is true and Q is false. P is false and Q is true. And P is false and Q is false. What should be the truth value of P implies Q for each of these cases? For the purposes of understanding what we will eventually accept as the truth table, let's say that we want to view P implies Q as being true, provided you don't feel that I've lied in saying so, and we want to view P implies Q as being false, provided you feel that I have lied in saying so. Let's investigate with a particular example. So consider the statement, if the weather is nice, then you can play outside. So this is a conditional statement, P implies Q, in which P is the weather is nice and Q is you can play outside. Using this criterion for deciding on what we think should be the truth value of P implies Q, let's look at each of the four possible cases. For each case, ask if you believe I've lied in asserting that P implies Q. In other words, ask if you think I've lied in asserting that this is a true statement. Okay, so the first case is P is true and Q is true. That means that the weather is nice and you do wind up playing outside. So have I lied in asserting that this is a true statement? No, I haven't lied, and so according to this criterion we should view P implies Q as being true. Let's look at the second case, which says that P is true and Q is false. So in other words, the weather is nice, but you do not wind up playing outside. So if I claim that if the weather is nice, then you can play outside, have I lied in asserting that that's true? And yes, I have lied, because the weather was nice and yet you didn't wind up playing outside. So in this case we want to view P implies Q as being false. What about the third case? This is the case where P is false and Q is true. So in other words, the weather's not nice and you do wind up playing outside. So have I told a lie? Do you believe that I've lied in asserting that if the weather is nice, then you can play outside? Well, not really, because it doesn't assert anything unless the weather is nice. So if the weather isn't nice, it doesn't say one way or the other whether or not you can play outside. And therefore, according to this criterion, since you don't believe that I've lied, we have to view P implies Q as being true in this case. Let's now look at the fourth and final case. So this is the case in which both P and Q are false, so that means the weather's not nice and you don't wind up playing outside. So if I assert that the statement, if the weather is nice, then you can play outside, is true, do you believe that I've lied in asserting the truth of that in this particular case? So once again, I haven't told a lie because this doesn't really assert anything in case the weather's not nice. So once again, according to this criterion, you have to believe that in this case, we should view P implies Q as being true. So with all of these four cases, we've essentially calculated the truth table of the conditional statement P implies Q. And so it looks like the following. I should mention that in the conditional statement P implies Q, P is referred to as the hypothesis or antecedent, and Q is referred to as the conclusion or consequent. So these four cases illustrate, and this truth table illustrates, that the only time the conditional statement P implies Q is false is when the hypothesis is true and the conclusion is false.